Much of today's explainable AI research is done from an algorithmic point of view. So we take an algorithm and wonder how can we make it explainable. But on the other hand, by its very definition, explainable AI should be human-centric. So we should shift our focus and start from the human side. So what explanations does a human need? And then from there, figure out how we can get an algorithm to produce such explanations. We're an industrial research lab. This means that in many ways we work like academia. We research, write and publish papers. But on the other hand, we also have access to real-world applications and the problems users face there. This can then inform our research, and in turn, with our research, we can have an impact on these applications. In terms of explainable AI, we can then make sure that through these applications, we develop human-centric algorithms. AI is already adopted in many areas, but they are often low risk. For example, it is easy to recommend a movie or a book to someone, but it is a lot more challenging and dangerous task to, for example, recommend a treatment to someone. So in high-risk areas, it's very important that we have explainable AI systems. So AI systems that already exist in low-risk areas are often neural networks, which are basically mathematical computations that a human can't follow. So when such a system makes a recommendation or prediction, we don't know why it is made. And this is fine for low-risk areas, but for high-risk areas, we truly need to understand why a certain prediction was made. So we need to understand why an AI system makes a certain decision, because it will help us understand what the AI system has learned in general. For model practitioners, this can help us to debug the system and improve them. And for expert users, it can lead to new insights that they weren't aware of before through the prediction of the AI system and its explanation. And overall, it can also help us understand whether we can trust a particular prediction or if the AI system might have been wrong. So one of the reasons why explainable AI has become popular in recent years is because before that, we were so focused on improving the accuracy of our AI systems. But now the accuracy is high enough for many applications. But for us to now adopt AI systems in these applications, we need to understand why a system makes a certain prediction. On the other hand, this is a very challenging task because we need to here look on one side at what the machine is doing and on the other side of what a human needs from this machine. One key algorithm that we've developed in our lab is called Gradient Rollback. During the training of a neural network, it tracks what this network is learning. Then after training, when we get a prediction from the system, we can use this information to explain why this prediction was made. We have applied this to the task of knowledge graph prediction. Many existing explainable AI algorithms do not make sure that they actually represent the true reasoning process of the model. This means there can be a mismatch between what the prediction is and if that explanation is actually explaining this prediction or rather something else. So when we developed Gradient Rollback, we wanted to make sure that we have a high quality explanation that truly represents the true reasoning process of the AI system's prediction. And now we're focusing on a new project which we call Explore and Explain, where we want to understand in human evaluation experiments how humans react to the explanations given by Gradient Rollback. Here we'd like to understand which explanations the human needs to make a better decision.
Orchestrating a brighter world. NEC.